because we think that those guys will, at the end, join the IEEE Italy section ExCo. So actually, it's the new generation. Another important point is trying to put together both the academy and the industry, because, you know, we are facing very important problem, and having the viewpoint, the twofold viewpoint is mandatory. Because of course we can make very good research, but this research should be also used to innovate, to increase, to enhance the everyday life. So the idea is trying to share the two viewpoints. That's why some of the young professionals are actually belongs actually to industry. You know, I'm the past chair, so since November we have new officers. So I'm sad, of course, because it means that I'm no longer young, but I'm also very happy because we made a very important election process using the MGA manual. So basically, we did all the stuff as it should be, and at the end we came out with this. 4 guys, Federica Battisti, who is the chair of the Young Professional Program, and of course we have the vice chair, the secretary, and the treasurer. So we have very important, officers, team of officers that of course is taking into account all the relationship between Italy section, but of course even with Region 8. So what's our point? As I told you yesterday, the idea is trying to help those people to have a smoother transition between the student status and the status of professional. So the idea is trying to have these 3 pillars that at the very end eventually are going to give back some expertise to the Italy section, because we think that at the end they will join the Italy section ExCo as a new generation of both members. With respect to our idea, our vision, so the vision of IEEE Italy section with respect to this young professional program is actually, you can think that IEEE Italy section is a sort of medium where the networking between young professional and student branches, because of course we think that there's a joint connection between young professional and student branches that need to be reinforced, and we are taking a lot of action from this point of view. So the networking between young professional and student branches, societies, Region 8, academy, and industry is actually taking place within the boosting action of IEEE Italy section. So IEEE Italy section is a sort of booster to actually develop new action, new strategies aimed at facilitating, at improving the networking with those 5 entities. The conference we are going to I had some messages that my network is pretty much unstable, so I hope that you can hear me. This conference, this workshop is actually an example of best practice that has been developed by 3 members of our young professional team, because 3 guys of the organized committee, of course Carlo, which is one of the general chair, but also other 2 guys are strictly involved in the organization of this conference. And so we are very happy because this is the first attempt of implementing what I told you here. So establishing connection between these 5 entities. So I'm very proud of this. I'm very enthusiastic of this kind of activity. And in framework of this conference, of course, they organized, I only made some simple things, but they organized. They made all the effort to organize this kind of event, which we think is very important, because actually it's a sort of roundtable. This Brunch with Leaders event is a sort of roundtable where are adding seat young professionals, student branches, Region 8, chapter and society, and of course industry and the leaders, leaders, industry, and academy. So it's a very important event that actually reinforced the cooperation between young professional, Region 8, student branches, and chapter society. We had a lot of email exchange, meetings, and so on. And I mean, young professionals were strictly involved in all these activities. So I think that IEEE section made a very good job in promoting this kind of activity and supporting this kind of activity. We are all very happy with this event. So I think that is almost on time. I'm almost on time. So let's start to describe which kind of event we are talking about. Actually, this Brunch with Leaders event will follow this kind of agenda. So briefly, we have some brief introduction about the leaders. So each leader will present a short presentation, a sort of pitch, which is focused on his viewpoint on this artificial intelligence and wearable sensors. So we had some, we will listen this kind of presentation, this kind of speeches, and then we are ready to discuss, because we have more than 1 hour open to discussions. We have also collected some SIG questions, but I hope that there will be a lot of questions from the ground, because I think that this is a very good opportunity. I mean, it's an unprecedented opportunity to meet those guys, those very important experts in a virtual conference. We hope that next year an event like this can be actually made on site, but yeah, you know, we need to take benefit of all the opportunities we have. So this is a very good opportunity, and I hope that you can enjoy it. So yeah, I cannot say, yeah, I should say stay tuned. Okay, thank you very much. I think that the next speaker will be Vinko Lesic, if I remember correctly.
Hello, Ferdinando. Thank you for the announcement. Well, thank you for the invitation to participate in this great thing that you are organizing. My name is Vinko Lesic. I'm an assistant professor at University in Zagreb, but here I'm on behalf of IEEE Region 8 Young Professionals, which is a segment of IEEE that Ferdinando already described, but it is a very diverse segment indeed, from master and PhD students to the high technical experts and even some management grade engineers already. So what we do, well, what the IEEE is doing, we connect people, we transfer the knowledge, and this is what the conferences are. So this is also what this AIM conference is targeting in this specific domain of high new topic. And today that unfortunately means that we are virtual, but fortunately that means that we can bring all the speakers from all the parts of the world and all the attendees to follow up the conference. And this is what we are doing now. Well, this Brunch with Leaders is also being streamed on our social media, which has like 5,000 followers from different parts of IEEE Region 8, but also beyond all of that. And by this, I think it will be really interesting to see what the people are thinking in general about this topic. But back to the organizers, Ferdinando and Carlo, thank you for involving us. And thank you also the Frederica and the Young Committee for stepping in the organization. And perhaps most of all, thank you all the speakers who are contributing to this panel. I see that it's really highly renowned, and some of the most prominent experts in the world on this topic, which is really new and which is really having an increasing attention recently in this world of academics. Well, this is all from my part. I will stay and participate in the discussions, but thank you all once again.
Thank you, Vinko.
Yeah, thank you very much, Vinko. It's yeah, it was a very great pleasure to exchange ideas and to have the support of Region 8. Vinko was very was a very nice guy to help us in disseminating the event and also in ask for funding from the meetup program. So I think that we can move to the next speaker, which, if I remember correctly, is Professor Paolo Maresca, which is actually the chair of the IEEE Italy section student branches. And as I told you before, we have a strong relationship within student branches, so it's very important to have his point of view. And I will thank him for all the activities he performed, for the help he made in promoting this event and in suggesting us ideas and also opportunities to be followed. So I will give it the word to Professor Paolo Maresca.
Thanks to all for inviting me, and I try to share my screen. Can you see my presentation?
Yeah.
That's cool. That's okay. Hello to all. I introduce myself. I'm Paolo Maresca. I'm Student Activities and Educational Committee Coordinator of the student branches for the Italian section of IEEE. What I would like today is give you a clear picture of what the student branch is in the IEEE Italy section today. Student branches are a hotbed of ideas, often an activity scene of a very varied local initiative and sometimes of international level. There is an opportunity to transform this predominantly local activity linked to the historicity of research into a collaborative Renaissance workshop, into a network of knowledge and skill that can be useful in many respects. Meanwhile, some numbers that characterize the Italian specificity of a student branch can be seen in the images that follow. Meanwhile, IEEE is the largest organization of the engineers in the world. It is divided into regions, and Region 8, of which Italy is part, is the largest region. It ranges from Greenland to Russia, from Europe to Africa, including Middle East, therefore a very high potential. Within this territory, there is the Italy section, which expresses 40 chapters and 3 affinity groups, and together with this significant number of student branches. In the vision that has been indeed for some times, in this vision, student branches tend to be an open innovation network, a Renaissance workshop in which people collaborate and cooperate to make ideas flow and transform them into innovations. Innovation is the application of invention, and a workshop in which the skill and knowledge acquired are often reused helps in the transformation. The numbers are interesting because no country in Europe has these numbers. The Italian students enrolled today at IEEE are 1,047, all the students, student branch and young professionals. With a growing female participation that has reached 16%, and with a distribution on all Italian institutions and research centers, now reaching 75 between universities, research centers, and institutions. A separate discussion is the type of engineering for which students participate in this association. The subdivision is roughly 1730. 70% is the class of classical engineering and 30% that of information communication technologies. That is, which is taking on an important role. Small percentages for the other two areas, which are that of biological and medical science, 1% for each one. But the question is, how many STEM branches are there? The conclusion for this slide is we have a huge potential for the student branch and young professional network within our region 8. How many student branch we have now? The numbers of the really active ones are the ones you can see in the chart. 21 student branch, 5 student branch chapter, and 2 student branch affinity group. But the participation of the students is much more substantial because it covers, as I already said, all Italian university, as it evidenced by the 3 snapshots you can see on the right side of the slide, which show us that all Italian high-level education institutions are involved. But what are the benefits and what are the costs? The benefits are many, ranging from the possibility of participating in a contest and acquiring awards, to the opportunity to use free services such as a free email opportunity, to use a free service such as IEEE television, being able to read magazine and newsletter, and have student travel grants, especially for PhD students and doctor of research, discount on IEEE Congress registration, and much more. But at what costs? A piece and a beer. That pizza and beer, a year of course, naturally. Indeed, $27 is a fee participation that are around 23 euros, as you can see in the and is IEEE membership dues of 2020. So we say that Italian student branch has a huge potential to coagulate other forces, and so it is happening with 2 events that we already launched with IEEE Day, Como, in 2019, and with IEEE Day 2020 in streaming together with IEEE Swiss Friend. The pitch competition event had enormously successful. A competition in that student branch and young professional talked about the year research, and 5 minutes video was really appreciated as an agile communication about their research. We intend to repropose it in an extended key in all Region 8 next year. But there are other important points worthy of attention. The first one focus point on the existing activities of the student community, because it can lead to synergies and new projects that can see more student branch involved. Today's conference is an example of synergy, in my opinion, because young professional in one open network of idea. Then there is the activity with an important, the second point is the activities with the large companies in sector covered by the 70-30 diagram, as you remember, that have not yet been involved in this open innovation network. I am referring to those of information communication technology, for example, huge player as IBM, Microsoft, and other, and also in the activity of the medical sector and of course sensors, obviously. And there are the activities to which IEEE is very sensitive on a global level, and are those that see a student branch involved in internationalization projects toward strategic and ethical activities. Also, other activities we are planning with the group Women in Engineering IEEE, because the presence of women is appreciated in all teams up to now. In short, the conclusion are that we would like to do in the next year. First of all, improving cooperation. The network is built and exists also thanks to the support of a young professional with whom we have a fusion of intent while maintaining the very nouns and the difference of categories. We would like also to increase the number of members, and the thermometer should be that of registration for the next year. Some rumors tell me that things should go well. For example, in student branch, we'll go from 27 people to 40 members. Communicate. This is an activity that we as Italians do not know how to do well, but we should do it. Knowing how to do is important, but letting people know is one of the activities of research, and we must work well on it. IEEE provides us with newsletter, magazines, and more to do it. And we should take advantages of these opportunities. Otherwise, what we do remain relegated to the border of Region 8. I would like to conclude my presentation with the contacts and links of formal and informal tools that you can find in news and network with us, with Student Branch now. Thank you for your attention.
Thank you very much, Paolo. Very nice presentation, and yeah, I think that we are almost on time, so we can introduce the leaders, the experts. So we are in the very hard part of the event. So I think that, as I mentioned before, actually we would have first some brief presentation about the leaders, and then we will have the discussion, the free discussion. So if everything is fine, I think that the first one is Professor Giancarlo Fortino from Università della Calabria in Italy. So please, Professor Fortino.
Okay, thank you for your introduction. So I guess I just got a couple of minutes just to introduce myself and also my research activity, just, you know, a very brief summary. Okay, I'm currently professor of computer engineering at the Department of Informatics, Modeling, Electronics and Systems of University of Calabria. My research focus is mainly on wearable computing based on body sensor networks. So it's, you know, it's very well focused on the workshop, you know, you are attending during these days. And, you know, I started working with body sensor networks since many years. It was 2006 in California, specifically in Berkeley. We launched a project called the SPINE, Signal Processing Node Environment. And this was funded by Telecom Italia Lab and Pirelli. They established the lab in Berkeley, and they were also supported by University of Berkeley and Intel in Santa Clara and other US and European universities. So University of Calabria was, you know, the leading actor in this project, and currently, you know, the project is an open source one, and we are maintaining the project in order to provide support to people who would like to use our middleware in order to create interesting BSN-based application. So this is something that you know, students need to know in order, you know, to contact us and stay in touch with us in order for us, you know, to support them in providing methodologies, tools, frameworks, and even best practice to develop, you know, body sensor network application, as well as also signal processing methods to be incorporated, to be embedded into body sensor network. So this research activity produced, I would say, huge research results, not only in the form of publication, you know, top-level journal, a lot of citations. You know, this year it is, you know, news of yesterday. I'm a highly cited researcher 2020. Okay, so by Clarivate. So I'm the only professor from Italy that is in this list, and this is mainly due, you know, to our research on spine and on body sensor networks, and also we have a book, interesting book, on wearable computing system based on body sensor networks, published by IEEE Press Wiley. So in my opinion, we got a very interesting body of knowledge to share with students that would like to approach this world from the perspective of how to develop body sensor network systems. Okay, so again, keep in touch with me. I will try to connect during the next hour, even though I need to you know, share myself with my class that will start at 11:30. But I will try to connect so that you can you know, ask me some question, or anyway, you can send me some question via email. And anyway, let's keep in touch. Okay, thank you very much.
So. Okay, thank you very. Yeah, okay, I'm not muted. Okay, thank you very much, Professor Fortino, for very nice talk. It's very important because, you know, I strongly recommend to all the attendees to keep in touch with Professor Fortino, because this, I mean, the aim of the event is establishing connection. So please don't be timid from this point of view. So I will introduce the next speaker, if I remember. Yeah, is Professor Emiliano Schena from Università Campus Biomedico di Roma, Italy. So please.
Thank you very much, Ferdinando. Hello everyone, and welcome to this event. It's my very great pleasure to be here, and I really want to thank Dr. Massaroni, Professor Nunziata, Professor Maresca, and Dr. Vinko Lesic for their kind invitation. My name is Emiliano Schena, and I'm Associate Professor at University Campus Biomedico di Roma, a young Italian university that promotes integrated teaching, research, and healthcare structures, pursuing as the main end of all its activities the good of the human person. Well, my PhD research focused on the management and monitoring of critically ill patients. I proposed a new control strategy to improve the performances of humidification systems used in invasive mechanical ventilation, and I developed a mechatronic active lung neonatal simulator to mimic the respiratory patterns of neonates and preterm infants. And I proposed a novel non-invasive technique for cardiac output estimation in mechanically ventilated patients. Well, my postdoc activities dealt with investigating new design of sensors based on fiber optic technologies and their application in life science. I started dealing with the interaction between laser light and biological tissue to optimize laser settings during minimally invasive procedures for cancer removal. Then I focused on the real-time monitoring of tissue temperature by fiber optic sensors to optimize the treatment outcomes of laser ablation. Since 2014, I've been working in the field of wearable systems with focus on the development of new systems for continuous monitoring of physiological parameters and vital signs. My group is exploiting this technology in several clinical settings for the optimal management of rehabilitation process and for monitoring critically ill patients, as well as in the field of worker safety and in sports sciences. Along my career, I've been involved in several activities related to the organization of scientific events to fight gender inequality and encourage more women into science. Also, for these reasons, in 2018, I founded the Italian Sensor chapter, and now I'm serving as chair. That's all. Thank you very much for this slot, and now I leave the floor to the next speaker, Prof. Benny Lu, or to Professor Nunziata. Thank you very much.
Thank you very much, Emiliano. Yeah, I think we can give the word to Professor Benny Lu. I think he is from Imperial College, if I remember correctly. Yeah, I missed my PowerPoint. So okay, so please.
Okay, hi. Well, first of all, yeah, thanks very much for inviting me to having this opportunity to speak to the young engineers or researcher in the field. So yeah, my name is Benny Lu. I'm a senior lecturer of Imperial College London. My research is pretty much about body sensor network, and so we work on the number of aspects from the very low level in terms of the hardware sensor design to communication protocol, security, to all the way to the data analytics and machine learning. The body sensor network concept was started at Imperial College, and we have been in the field for quite a long time. And in terms of the applications, we have explored quite a number of areas, from well-being in terms of health, and also for medicines and sport applications. So for sports, we have quite a number of research work about how we can use those wearable devices, sensors, for capturing those biometric biomechanics informations in the field. And for the health or well-being, we have been working on a number of different sensors, from optical to electronics to biochemical sensors, to see provide this kind of what we call pervasive sensing, right? So continuous sensing to help monitoring the patients. I also work on some other aspect of sensors in terms of, rather than just the sensor itself, we're also looking into wearable cameras now. So cameras can be considered as a sensor. So we're currently looking on some of the dietary intake, so what food you eat. But in general, what we can see, the number of, or the use of the wearable sensors is growing. And under the current COVID-19 pandemic, I believe there's a great potential that this type of technologies, low-cost wearable devices, could make a change can make a difference in terms of lowering the cost of care and also minimizing the risk of getting infections. So the patient can stay at home rather than have to be go into the hospitals. So I'm very much work very closely with the IEEE EMBS society on the wearable sensing aspect, and involving quite a number of conferences, workshops, and so on. So we do have a conference of Body Sensor Network, and we also affiliated with the journal, a couple of journals as well. So thank you very much for giving me this opportunity to join this exciting event, and I'll pass to Stefan.
Okay, thank you very much, Professor Benilo. It's a pleasure for us having you here. And so we can move to the next speaker, who is Professor Stefan Leonard from, I think, from University of Aachen. So it should be Aquisgrana in Italy. Yeah, in Italian. Yeah. Please.
Yeah, it is indeed Aquisgrana. So hello, everybody, and thank you, Benny, for passing over. My name is Stefan Leonard, and I'm chairing the Philips Endowed Chair for Medical Information Technology. And one of our strategic areas is indeed body sensor networks. We have also been involved in the body sensor network conferences that we had together with Imperial and many other partners around the world for many years. And we also operate a body sensor network that we have designed ourselves for synchronous measurements of vitals as well as motion. And we do apply this especially in the area of geriatrics. We have recently established a new lab of geronto technology to quantify movement of impaired elderlies especially. And this brings me to another step that I also think is important, because when we think about wearables, sensors are important, but it's not the only thing. We should also think of actuators. And at the moment, we have an initiative to combine wearable sensors with wearable exoskeletons for helping impaired people, especially stroke survivors. And here, the body sensor networks will produce the trajectories, especially if we measure the healthy side, which is still functional, to give reference values for control of the impaired side, where we can actually assist movement. So I think these are nice fusions for the future, and I was asked to also talk what's hot in the moment. I think that's one of the areas that I think the body sensor network community should look at. Thank you.
Thank you very much, Professor Leonard. So I will give the speech to Professor Leandro Pecchia from UK, I think from University of Warwick. Yeah, should be.
Thank you, Ferdinando. Yes, I'm from the University of Warwick, although as my friends often say, I'm made in Italy. My main contribution in this area of research has been to review and contribute to rephrase the way we analyze signals when we know that those signals are coming from wearable sensors. So we are not anymore in a clinical setting, we are not anymore in our comfortable zone in an hospital, but the patient is wherever. And now, when you do that, then obviously you have to take account so many factors that you have to make your signal processing more resilient, especially if you are going to use those signals in a machine learning or artificial intelligence application. So our expertise lies exactly in this area. How should we change the signal processing if now I know that the signal is coming from a wearable sensor and I'm going to use it for a machine learning, deep learning, artificial intelligence application? And in the past 10 years, we gave few contributions in this direction. And we believe that the way you analyze the signal should be completely reformulated now that you know that this signal is not coming from an hospital, possibly is not stationary, the subject is not standing, is probably moving, and you don't have the direct control of what's happening in real life. From the scientific point of view, this has been probably my main contribution of my lab in the past 10 years. Now, in the last 12 months, we have been granted several grants. I mean, just to give you a few numbers, 40 millions of euro as a consortium, not all for my lab, but with the Gatekeeper, Odin, and 3 more national projects. The first 2 are European ones. And they are all in the space of Internet of Things. So not only wearable, but also sensors you can place in a room. As Benny was saying before, also a camera is a sensor nowadays, and you can detect so many parameters from motion, but also heart rate variability and other stuff like that. And so the fact that the European Commission has been investing 40 millions of euro, that's what we got as a consortium, 60 partners, but this is also a significant proxy for the level of attention that this kind of technology is having in this moment, combining together wearable sensors, probably broader than that, IoT, signal processing, and artificial intelligence. So for all the early career attendees of this meeting, probably, then if you're working in this area, you are doing very well. And just to give few numbers to give you an idea of how, in my opinion, this is evolving, do you know how many patent applications we file per year only in Europe in the space of medical devices? In case you don't, this is 12,000. And 12,000 novel patent application means 1,000 per month. 1,000 per month means that over 20 days per month, we work about 20 days per month. It means that this is what, 50 novel patent applications per day, only in Europe. And now, if in Europe we work 10 hours per day from the very east to the very western part, it means 5 novel patent applications filed every hour. And this means that by the time we are running this webinar, 2 hours and a half, 13 novel patent applications will have been filed while we talk, while we reflect on this topic. And that's important because if you consider the time to the market, 10 years ago, from the patent to the market, we were saying that you need 10 years. But now, especially in the domain of digital health, sensors, apps, this is very short, it's 1 year, because otherwise you end up in obsolescence. So if you combine those two numbers, the number of patent applications per year and the time to the market, this means that we are going to face a tsunami of technology in this space. And we need people as you, trained and sensitive to this topic, in order to be sure that this opportunity is not a wasting of money. We really use it to increase the quality of life and to serve better our patient or just senior citizen. I work in the space of active aging. They're not patient, they are just senior citizen in my view. Thank you. I think I took even too much, and I will be more than happy to answer your question later.
Thank you for these impressive numbers. Yeah, let's move to the next speaker. We ended with the academic viewpoint. Now we start with the industry viewpoint. So the first speaker, I'm very happy to welcome him, is Dr. Christoph Guger from. He's the CEO of the GTEC Medical Engineering.
Thank you very much, and nice to be in the conference today. So I'm coming from GTEC, and this company is based in Austria. So our headquarters in Graz and in Schiedlberg in the north of Austria. This is where we do our software and hardware developments for brain-computer interfaces. And then we have also an office in Barcelona where we do software development. And we have also sales offices, for example, in New York, Albany, and in Hong Kong. At the moment, we are involved in about 15 different research projects. They are mostly from the European Commission. Some of them are also with the US. And we use brain-computer interface technology for many different applications like stroke rehabilitation, coma assessment, deep learning, and so on. So all what we are doing is related to neuroscience. And that's also the reason why we developed wearable EEG sensors. So this model here is, for example, wearing an EEG cap with 64 EEG sensors and 8 FNIRS, functional near-infrared spectroscopy sensors, so that you can investigate what is going on in the brain while you are doing certain tasks. And recently we developed even a 1024 channel brain-computer interface. So in this picture, you can see that these grids are mounted on the subject's head. And with this setup, we can see a never possible resolution of EEG data than before. So you can just imagine traditionally people are doing 32 or 64 EEG channels, and with this technique, we can even mount more than 1000 channels on the human brain. And this leads to a very high resolution. And we develop also a couple of clinical applications. So our brain-computer interfaces are used, for example, for coma assessment. So in this case, a coma patient can even answer yes and no questions by using the brain-computer interface, or we run also rehabilitation centers where we are treating stroke patients with BCI technology. And just in our own rehabilitation center here in Austria, we had treatment 10,000 in September this year. And for the consumer market, we have another wearable device, that's the Unicorn. That's an 8-channel EEG headset, which allows you to run all major brain-computer interface experiments. And this is also very useful for acquiring EEG data from a lot of people so that you can use it for deep learning applications, or we use it also in hackathons, in these Brain.io hackathons, where people meet for 24 hours to develop new applications. So that's a quick overview. Thank you very much.
So thank you very much, Christoph, for a very nice overview of these high-level activities. I'm very happy to be here. Let's move to the next speaker, who is Dr. Paul. No, it's probably Dr. Angelo. Yeah, because it was working.
Yes, I'm not Danilo. I'm not Danilo. I will speak also about him. That is a colleague of mine working on different aspects in artificial intelligence. He will join later, so I will also provide an overview about his work. First of all, I want to thank organizers who invited us to attend to this event. My name is Arcangelo Bruna, and I work more or less from 20 years in ST microelectronics in artificial intelligence fields. I want to make an overview of my company. ST Microelectronics is a worldwide company with 40,000 people, more or less, and more than 7,000 people working on research and development. It is a semiconductor company with a huge product portfolio from transistor in different technologies, CMOS, silicon carbide, GaN, and so on. Also from simple integrated circuits to more complex integrated circuits. In terms of sensors, we have a lot of temperature, humidity, pressure, inertial sensors, microphones, MEMS microphones, imaging sensors, time of flight, 3D time of flight sensors, and so on. And also microcontrollers. So STM32 is the I suppose a well-known family, and it is also available in the mass market from a couple of years with dedicated boards called the Nucleo boards that are low cost, dedicated also to smart prototypes. And then we have also new multimedia platform units, in particular an STM32MP1 is the name, with a dual core ARM processor for more complex analysis. We also produce a system on chip embedding several components together in order to reduce the size, the power consumption, also the time to market for sure. And ASICs that are dedicated chips customized for particular customers. So, and the market ST Microelectronics is serving is very huge, from automotive to Internet of Things, to industry, to smart home, smart cities, computer and peripherals, and so on. Almost everything, I have to say. So myself and Danilo work in R&D group, and we are focused on artificial intelligence. I am principal engineer and then senior member of IEEE, while Danilo is a fellow engineer and is IEEE fellow. Both have written several patents and papers. Both of us have a background in imaging processing and compression, video compression, and now we are fully dedicated to research and innovation related to artificial intelligence. And we are in our company, we are approaching the artificial intelligence study in two directions. The first one is to enabling with our portfolio, product portfolio, artificial intelligence application in several fields. And the second stuff is to simplify also algorithm integration in our microcontrollers. In particular, in this task, Danilo is more focused on this task and is dedicated to neural network integration. I mainly focused on algorithm development, integration in our platform. The last focused projects are related to robotics, in particular navigation using different sensors, from LiDARs to inertial sensors, so accelerometers, gyroscope, magnetometers, also imaging sensor, time of flight, and so on. Among the algorithms, there are free navigation, obstacle detection and avoidance, also SLAM, so-called simultaneous localization mapping. I'm focused also on biosensors, electrocardiography in particular, and electroencephalography for brain-computer interface. Just to make an example, to detect brain waves and to use retrieved information as a remote controller, or trying to predict hands motion and to replicate this movement in a robotic hand and so on. This is for myself. About a few words also about Danilo. Danilo is focused on edge AI and tiny AI to perform AI as near as possible to the data sensors. As you know, probably this is very important for wearable devices. It allows to reduce, in fact, the bandwidth, the connection, to reduce also the time to action, to enable also Internet of Things, where millions of devices should be connected together, just transmitting a few data instead of the entire stream. He's driving the development of a tool also already in the market called STM32CubeMX.ai, aiming to map a complex neural network in our microcontrollers that are written in a high-level framework, Python in Keras, using also MATLAB and so on. In this case, execution speed and I don't know what's happening. Okay. I hope you can hear. Something strange happened in my desktop. Execution, sorry?
We can hear you perfectly.
Okay. In this case, execution speed and smart memory management are for sure the two main challenges in to embed a convolutional neural network, also recurrent neural network or whatever else, in a microcontroller with a few memory and limited CPU speed. I have to say that there are also other challenges to be addressed. For sure, we have to stay up to date with any topology, to analyze also hardware and software partitioning, to speed up processing and proposing hardware accelerators and so on. That's all. Just the last thought is about how our job is linked to the wearable device. For sure, there is a strong link. The products where we are focused are an important pillar for wearable devices, where low power, low resource computations are mandatory, since wearable must be battery operated for sure, so they will not consume a lot of power, and partial or also fully functionality should also be on board near to the sensor. So that's all from my side.
So thank you very much, Arcangelo.
Thank you.
Nice presentation. This ended actually the room dedicated to the presentation from the experts. So I'm very happy because actually we had very nice presentations both from academia and the industry. So I think that now we can move to the open discussion. I think that I listened very carefully to this presentation, and of this field, I think that there are some some buzzwords. That of course, one of these, of course, is wearable sensors. That's for sure. But I also understood that it's very important to have very good actuators in order to have effective wearable sensors. And you know, it's also important that we need to take into account. We need to take into account that medicine is moving also out from the clinic, so it's also moving at home. So it's very important to understand how this exchange of information and this can be performed. And is you know, since you have all these sensors, it's very important to understand how to process this large amount of data. I think that's for sure. It's a very large, it's a very huge amount of data, so it's also important to understand if there are suitable techniques to work with big data. And of course, the role of artificial intelligence is, I think that is a very, very central role. So I think that all those keywords can be, I mean, you know, at the basis of the discussion from the attendees. So first of all, I thank you all the speakers, and then I will try to move to the attendees. So I will have a look at the question and answer. You know, there's this very nice question and answer tool from Zoom. So I think that you can just write the question in the question and answer tool if you are quite timid. Otherwise, you can also raise your hand, and we can, of course, give you the word. So it's up to you. I mean, it's yeah. So is there any question from the ground? It's not actually, yeah, mine is not a question. So for sure, we need question from the ground, because the aim of this I mean, the aim of this event is not providing listening in a passive way the presentation of this very important speaker, but to take the chance to interact with them, because it's a unique opportunity to having all of them at the same table. So yeah, it's very important. If you have a question, actually all the questions you have, it can be technical, it can also be, I mean, in terms of opportunities they can give you. Okay, there is I don't know, there is something in the chat. I will it's so yeah, you know, I think that it's always a strange time, because sometimes people are very timid. So I think we can start. Okay, there is a question. Okay, perfect. So I will read it. I don't know if the panelists can read the question. I can read it, no problem. So, how the link between academia and industry enhance the already on market products? Sorry, I have some problem with my screen. Carlo, can you read this question? I have some problem with my screen.
I can read it, Ferdinando. They are asking how the link between academia and industry can enhance the already on market product. Basically, they are asking probably about the interaction between academia and the industry. They can improve, they can make some difference on the product that are already on the market.
So I think that if one of the panelists can, there's no problem. You can ask.
I think it's a very general question. Probably they would like to know about.
If I can break the ice,
please.
So the number I was giving on the patent application, which obviously not all the patent application become a medical device, but that's a proxy. So this gives an idea of the future. Is also another relevant information, because what we do in this field is probably not theoretical physics, but it's rather very high TRL things. So if our research does not end up into a product or a service or something relevant for the patient, probably our research is not good. So in this particular field, I believe it's crucial to have this strong link with the real world. Otherwise, we would just do theoretical physics, and that's what it is happening. And I think it's a very rewarding field, but probably in the domain of nanoparticles and optical things, that's where I see the most interesting things coming over the next 10, 20 years. But if we stay on the wearable side, artificial intelligence, signal processing, this has to be translated in real life. So yes, this is a crucial link. 87% of companies making medical devices in Europe, I don't know in USA and Asia, but in Europe, I know very well the situation, they are small, medium enterprises. And this means that those companies are made of what, 3, 5, 20 people. So they have to be very close to the research world, and they must probably have a PhD themselves. And this field is probably the only one in which, well, not the only one, but is the one in which there are more engineers with a PhD. If you compare our domain with what you see in automotive, in aircraft engineering, whatever else branch of engineering, you will never find as many PhD as you do in this space. And that's because here, the link between research and real world, there is no distinction, it's in overlapping. So thank you for this question. I don't know who asked it, but that's a very good question. And yes, as a student, you should already project yourself in this link. And that's my opinion on this point.
So you would say that preparing for a PhD, I mean, considering to attend a PhD is for sure a good idea to make the
I am a biomedical engineer in particular, so I see sensors from the point of view of biomedical engineering. And in biomedical engineering, in the field of medical devices, you don't even sell a medical device if you don't reflect on the research. In order to sell a medical device to the NHS, to an hospital, you have to run an health technology assessment, which is research. So if you don't know the principles of research, if you have not done yourself, you will never be effective. And that's just selling. But before selling, there is design, assessment, regulatory framework, maintenance, disposal, and this all requires research. So I don't know one good company of biomedical engineering which doesn't have at least half of people employed which are PhD. In Italy, it's not as clear as in the UK, but
that's the point. That's the point. I mean, that's the clear message for the audience. If you want to make a bit of difference in this field, you can consider to go on studying and to start learning the research. So I think this is a clear point and a good message.
Thank you, David.
Before moving on the next question, also the point of view from the industry, because you know it's it's a good point.
Yeah, I just I completely agree with Leandro. The academia can support companies, but also the company can support the academia, because in most cases we need the support to further increase the TRL, the technology readiness level of our product. So usually we are able in some cases to develop systems and to reach a technological readiness level of 4, 5, but then in some cases we need the support of a company to further increase the technology readiness level and to make our research a product that can improve the quality of life in case of wearable technology of people. So
very nice, very nice. Thank you. We have Carlo Massaroni that would like to make a comment about the previous question. Are you there, Carlo?
I completely agree, and I think that academy should be linked with the company, and industry may help sometimes the academia and the research to be much more linked with the applications in real scenarios. And that's my point. I completely agree with both Professor Leandro and Emiliano. I'm really interested to know the point of view of the industry, just because we have Arcangelo Bruna from ST, so really close.
Yes, please.
A link between academia and industry.
Your idea will be very welcome.
I can provide my comment from this point of view. I strongly agree with both that academia and industry must be connected, fully connected, because as a company, for sure, we want to sell our products, but it's just the last phase of a cycle. The cycle starts with analysis of a problem, of modeling of the problem, and how to solve it, and how and what is needed to solve the problem. So it is the basic stuff to start, and the last should be the product. Okay, but in between there are a lot of stages that require a hard interconnection between academia and industry. We as R&D guys work strongly linked with the universities. Thesis and PhD, as you said, are the main bridges between university and industry, where to join and provide the information from the university to the industry and back, thanks to our customers' needs, to the industry, to the academia again. So this is what we do. It's a multi-year work for sure, not simple. Sometimes it fails, but anyway, it is needed.
There is also a question that is strictly connected with this topic, and it's about the possibility of gaining some experience during the thesis in the industry framework, and then going back to the academic environment for a PhD. But probably I would also add that there are some possibility to do the PhD in the industry, right? So what you can say about this?
I can say that we have both thesis and PhD. For sure, the thesis is more simple because first of all, we start from a joint program between the university and industry, for sure. Then we split it in sub problems. And some of them can be addressed with a thesis. I have to say that the thesis today are 3 months more or less, and it is not quite simple to detect a particular task that can be solved in this few time. But from time to time, the guy that works on the thesis will continue also with PhD, and I suppose you know there are some PhD that are funded by us, but some PhD there are also the last call for AI PhD, if I well know said well this name, and because also the Italian state is considering AI very important, and so I guess that it should be catched by students.
So we could summarize that the PhD is not a unidirectional process. I mean, if you want to do something that is shared between industry and academia, it's for sure possible.
Yes. Sure.
I don't know if some other leaders would like to comment on this.
I can maybe comment from the German perspective and also from semi-industrial. I've also served 5 years in industry, but of course I'm back in academia for quite some time now. I think it is very important to have such links, and especially in Germany, I think 3/4 of my funding comes from public-private partnership projects. So we do this very extensively, and I completely agree what has been said. In biomedical engineering, pure research, theoretical research is maybe not very useful without the application aspect. On the other hand, PhD, if you leave to industry, and chances are you get used to a different way of work style, which makes going back not always easy, I think, and that is more a question of personality change and adaptation to a different lifestyle than the question that this is not possible. But those who have left my lab, and I have about 500 students leaving my lab over the 15 years that I'm in office, once they're gone, it is very rare that they apply back. I completely agree that a PhD is very helpful also in Germany, especially in biomedical engineering. Keep in mind that all your customers, your partners in the clinical field are all carrying a doctorate degree as well. So this is also a question of standing in the interaction, I think, but also from the research perspective. But it is also a question of that if your lifestyle changes, if you're getting used to more money, which also is an issue, then coming back and again, having the student lifestyle is not so easy if you have a family with 3 kids who are very hungry.
Good point. So I don't know if the other leaders would like to give the perspective from other countries, or an Italian one, please.
Right. Of course, I agree with Stefan's. Well, from our side, like we don't have that many industrial funding. Our funding is more for government funding because of the UK system. But we do seek opportunity to collaborate with industries because not all our students want to stay into academia, whether the PhD or master students. We want them, well, ideally, as like what Stefan has done. Maybe some of them can go into industries and help the industry to grow. But we do face a number of challenges, of course. Having industrial collaboration, there's also a little bit of IP issues and so on. But in general, we do keen to work with industry. And in the UK, it's a little bit tricky at the moment, like Brexiting, and we don't have the European funding vehicle to help having kind of a European project linking industries with the companies. So on the other hand, we do have some industrial academia research funding kind of projects to initiate those kind of collaborations. Yes, in terms of PhD students, yes, ideally it would be great to have an industrial PhD. So you probably work in a company doing part-time PhD, then you have maybe the best of both worlds. You have a reasonable pay job while doing your PhD, but of course it's not that many opportunity like that. We often find that we have a very talented student, but no funding, or they have to go back to work to support their family. So this is the reality of the PhD research. But in general, yes, biomedical engineering research, like as Stefan mentioned, we have to work with clinicians, doctors, surgeons, and having a PhD will definitely help to have conversations, and also in many ways having understanding of, because we are in engineering side, more in engineering side, but the clinical or the medical side, they use sometimes they use different terms, different wording. Having been able to understand what they're talking about is very important to have to understand their need. We need to understand their need before we can develop a system or technologies to help them. So that's what I think.
Thank you very much for these ideas. And if there are no other comments on this topic, we can go to the next question that is a bit different. We talk here about the acceptance that people in general can do about this technology. We know that wearable sensors and artificial intelligence, all this connected technology, need to be accepted by people. And when we develop a product, when you develop a new technique, a new product, or a new idea, you keep in mind this and how it's possible in general to make this process smoother, easier. I don't know if there are some leaders that would like to comment on this. They talk about the user acceptance of invasive technologies. I mean, wearable sensor, I need to consider that I need to carry on with me this sensor all the day or something similar. So this is a point that should be considered.
Yeah, just a short answer, mostly regarding the wearable sensors and the wearable system, not just artificial intelligence. I'm not so expert in that.
Yes.
Well, I think that the first step is to, of course, to consider the acceptability and the usability of the system. And probably one step can be, of course, to figure out what is present in the market, what is the state of the art, but also to face this problem by considering the point of view of the people that will use the system. So I think that the first step is to figure out what are the needs of the people that are going to use this system, and what are the main concerns, the main potential concerns related to the usability and to the acceptability of the system. This is a general point of view, but I think that this can be the first step to prevent some concerns, some issue related to this aspect.
I believe there are also some privacy issue, as you can imagine. So probably we should also keep in mind this very important aspect, right?
Absolutely, absolutely. This is an important aspect. I think that it's not easy to face with this aspect.
Yeah.
In particular, in the last 1-2 years. So absolutely, I think that it must be considered. And
let me do an example. In Italy, we were developing, as we already know, the Immuni app. And we know that one of the reasons why probably is not having a great success is mainly related to privacy issues. So, because people, even though all people have in their pocket a smartphone, they do not download the app. So this is this could be a clear example that the industry and the research should deal with this important point, I think. So,
I don't know if this is an example, but this is a very, I'm gonna say, general purpose app. So probably there is a strong impact on the media on this specific topic. So I don't know if it's the same with if you develop specific wearables for, I don't know, specific patients and so on. Probably it's quite different. Other leaders can answer better than me.
Yes, I believe there is a difference between biomedical application or other kind of application, I think. So I don't know if there are some other leaders that would like to comment on this or on other topics, please. If not, we have a question for Dr. Guger, and they were asking, what do you think about Neuralink? So I cannot help on this because I don't know what's Neuralink. So I don't know if it's enough. There are enough information to ask this question.
Sure. So Neuralink is the company from Elon Musk. That's the guy who is running Tesla. And he started with Neuralink a few years ago. And at the moment, they're building a 1,000 channel device that can be implanted. And they're also building a surgical robot, which is automatically opening the skull of a patient or of a person. And the goal is that the implant is done automatically. So the approach is very nice. And there are also many universities working on similar applications. This is also very useful for paralyzed people if they want to control their environment, exoskeletons or some computers. But the main purpose of Neuralink is to build it for the consumer market so that you can actually read out information of the human brain and hook it up to the internet. So this is a very far-away goal, but for handicapped or paralyzed people, it's definitely useful to have such an implant. Neuralink posted a few weeks ago a video where they implanted the device in an animal, and they could nicely show how the gait of the animal was restored with the implant. But like mentioned before, there are a couple of universities, for example, EPFL in Switzerland, who have done very, very similar things, but the research that they're doing is very nice. And for us as GTEC, it's also very good because Neuralink and Elon Musk are making brain-computer interface technology very well known. And that's the reason why a lot of people just purchase equipment from GTEC to do such research and experiment.
Okay, thank you very much. There is another question for Dr. Guger again. How does BR4IO competition works, and it is open to the student branch? So I don't know this competition, so probably you can help with this.
So Brain.io is our brain-computer interface designer hackathon that we are running now in year 4. So every year we do about 6 or 7 hackathons. They are mostly attached to bigger conferences or festivals. And normally people are signing up to work on brain-computer interface applications for 2 days. So they have to submit an application and they have to join a team. So a team has normally between 4 and 5 members. And then they get 24 hours to come up with new brain-computer interface applications. And normally we have programmers, artists, computer scientists, biomedical engineers, neuroscientists, and so on working together. So it's very innovative, and it's amazing what these teams can realize only within 24 hours. So at the beginning, we give some lectures. So we show them how to run brain-computer interface experiments. We explain them the hardware and the software they need. And then they have to use the equipment and do some experiments. And at the end, they have to give a presentation of what they achieved in the last 24 hours. And we always have an international jury. So they are looking at all the presentations, and then we select the winners, and we have also big sponsors on board like IEEE Brain. And then they get also some cash money and some certificates. And that's just very innovative. Because of COVID-19 this year, we started also with dataset analysis. So we provide datasets of epilepsy patients, stroke patients, coma patients, and so on. And then people can work on signal processing. So they can test or develop new algorithms and see if they can extract more of the data. They can also do deep learning. And so this year, a couple of the hackathons were virtual. This means people from around the world joined in. So in summer, we had, for example, one attached to our brain-computer interface and neurotechnology conference. We had about 200 people joining the hackathon, and they were coming from Italy, of course, Europe, but also from Argentina, Australia, Japan. So the whole world was joining into the hackathon for 1 weekend. And it's just a very nice learning opportunity. If you want to do something with BCI technology, you can get to know how to use the hardware and the software, and it's also nice to connect with other people. And if you want to do your master project or your PhD, it's also very useful to join in, because there are many professors inside, and then you can just see where is something ongoing, and you can maybe define even your PhD project. And it's open to anybody, so everybody can apply. We have also some hosting institutions in different nations. So these are people who have a couple of BCI systems available, and they provide it at their universities. And then students can come to the university and borrow the BCI system for the hackathon, or they can even take the brain-computer interface to their home and work at home, which is now very interesting during COVID, that you can still do something. And one of the hackathons, for example, was in Russia, where we had hosting institutions all over Russia. So in St. Petersburg, in Moscow, in Vladivostok, really everywhere. And we have also hosting institutions in Chicago or in Dubai. So it's a very good chance to get in touch with this equipment.
Thank you for this very detailed answer. We actually have another question for Professor Picchia. they are asking about the possibility of inserting machine learning techniques into disposable medical devices. Can this be the key to help the third world developing in the medical field?
Well, thank you for this question. We are working a lot on application of machine learning to answer needs arising from lower resource settings. We don't use the word low-income countries because, as often it happens, you are in a low-income country, meaning the GDPR per person is low, but then you find capital where they have great hospitals and facility. And the same applies to Europe. We are a very high-income country, but there are some remote areas where you work in limited resource settings. If you go in the island in the UK, or if you go on a remote island in Italy, you don't have the same facility you may have in London or Rome. So we work a lot for limited resource settings with United Nations, with WHO. We ran 7 field studies in the last 18 months when it was possible, so before COVID, BC. And no, I don't think that's the answer. We are using a lot of machine learning for supporting gaps that we find in Africa. Main one, I work in Africa, similar things applies to other lower income settings. The answer is yes, you can use machine learning, and there is a clear need for that because there is a lack of specialized knowledge. There is a clear need for giving answers when you don't have the knowledge in real time. So there is a clear need for telemedicine. There is a clear need for remote support, second opinion, and probably Africa is the place where we will see significant advancement in terms of closed loop control applied to medical device, because there is a clear need. And from the ethical point of view, you will never start using a closed loop control device in medicine in Europe where you have enough clinicians to do that. But probably in a low resource setting, you will. So that's a very good point, and machine learning will play a huge role in that. But I don't like the use of the disposable. The problem in Africa is often linked, and again, probably is the same elsewhere, but mainly in Africa, I know well, the problem is the supply chain. If the problem is the supply chain, then why a disposable should work? Probably the answer is in circular economy. The work we are doing now, David, one of my PhD students, is using 3D printing for local manufacturing of filters for oxygen concentrators, because they get the machine, the oxygen concentrator, they will never get enough tank of oxygen because the supply, well, not yet, in 5-10 years, probably they will, certainly they will. But they use mainly oxygen concentrator, just to give you an example. Oxygen concentrator is a device which is what, 2,000, 3,000, 5,000 euro worth. I mean, that's the range. They get it out of donation, they can buy it, and that's fine. I mean, that's easy. But that they don't have enough clinical engineers to maintain those. They don't have spare parts such as a filter. So you get machines which are not in use because they lack spare parts, which otherwise would be $2 as a filter of oxygen concentrator, for instance. So disposable is not the answer. Circular economy can be the answer. So if the question was, can we use 3D printing and AI to let Africans develop their own medical devices to face their current challenges? Probably in 10 years, they will be richer than we are. The answer is yes, we are working in this direction. We have at this moment 3 PhD students, Usola, Davide, Katie Stoke working on that, and 1 senior fellow, Marie Curie, Alessia Maccara. So yes, that's, in my opinion, we can and we do. And that's a duty of call. We should consider also other than just high-income countries when we work on design of medical device. But I didn't like the reference to the disposable, because the problem of Africa is the poor supply chain. And with the disposable device, you have the supply needs more often. So yes, you can use AI, but please approach more circular economy principles rather than consumable. I don't know if I answered this question, but I'm happy to give more details.
I think so. This is an excellent point and an excellent answer. And there is another one. There is another point, and very important. I think it's a very nice question. They talk about the possibility of developing this technology related to physiological parameters to prevent crisis situations such as the one we have been living for more than a year. They are talking about the COVID-19 emergency. For example, remote monitoring, leaving patients at home, and if they don't need intensive care. So could be the way to lighten the healthcare system without leaving anyone behind. So in other words, they are asking which could be the role of this technology to help preventing and to help managing this emergency that we already know.
No, thank you. That's a very timely question and very linked to what we were discussing before. The COVID has actually de facto created in Europe a situation of limited resources. And this linked very well to my opening. I don't work for low-income countries. I work for limited resource settings. And now because of COVID, we are living in Europe a limited resource setting scenario. You don't have the mask, you don't have the gloves. And that's something that Europe has never seen since the last World War. So we are de facto in a limited resource setting. In a limited resource setting, it's true for Africa, it's true for Europe, it's true for the States. Yes, AI, telemedicine can do a lot, but we need responsible approaches now. Regulatory issues are there, privacy issues are there. We don't know yet how to regulate AI. So we have still plenty of questions. CE marking is important. We have now waves to CE marking due to COVID. So there are fast track for COVID related issues. And I've never seen, I mean, that's also a great opportunity. We did a project on telemedicine for supporting oncological patients. As you know, they cannot enter the hospital because they are frail, they should stay home, but they're still in need of continuous care. And so I've never seen, we got an NHS grant, which is coming from the NHS and it's targeting innovation. Well, an hospital in Wales, I was just providing some guidance as external partner. I've never seen an idea responding to a grant and entering the NHS in 3 weeks' time. Normally, probably Benny can comment on that, and they are very good in that at Imperial, but normally it takes more than 1 year to move from the idea to the answer to the grant to the hospital. That's probably in the best case, also because just the ethical approval takes, what, 6-9 months. In this case, we did it in 3 weeks. And that's unprecedented. As every time in human history, huge crises trigger also amazing responses. And we are lucky because we are living a pandemic, which is not a war, is not the Black Death or the Spagnola. I mean, they were much more deadly and dramatic. I mean, I still have warm water at home. That's a comfortable crisis eventually compared to other more critical events. But this is triggering amazing answers. And if we managed to bring an app into the NHS in 3 weeks, it was a pilot and there was a great team. I was just giving few suggestions. Well, that's unbelievable. And we should all consider doing that. There are plenty of opportunities. Europe has invested 150 millions of euro in the last 12 months on ICT, AI, and they have asked us to focus on COVID. I can put in the chat as gatekeeper, pilot manager. We have now an open call, which is welcoming additional partners, additional technologies which are not yet in. So we have budget to support whoever is interested in joining the consortium. But we are not the only one. There are other 3 large-scale pilots. Blue Beer, another 2, I cannot remember the name. Altogether, this is an effort of 150 million of euro just in Europe in the last 18 months, focusing on digital health, AI, IoT. I've never seen something like that before. And they're now asking to open this effort towards COVID or whatever will come next, because we are now entering the multi-pandemic era. So COVID is dramatic because it's an affection of airway, and that's a big issue. We don't know the next one, but we have to learn now and do as much as we can in order to be ready. And this was, probably dramatic. So to answer your question, yes, COVID is creating in Europe a situation of limited resource setting. Therefore, my answer applies also to Europe. Yes, ICT, digital health, AI are doing and can do a lot.
Please, thank you again. Please, Benny Low, the professor.
Yeah. I completely agree. Yeah, because yeah, never seen any ethical committee can pass 3 months. Usually we take at least a year for something very straightforward, even for patient trial, for getting ethics. And in fact, a lot of technologies have been developed. Telehealth is not very new, right? Wearable technologies have been around for a number of years. But COVID has helped to change people's mindset. We used to be kind of like going to the hospital or going to the clinic, going to see a GP if you're not feeling well. But now, with the new norm that we better not go to the GP if you're just having minor symptoms, or even if you're COVID symptom, you have better stay home, still stay home, not go to the GP or hospitals. And there's a missing link is of course I believe at the moment a lot of GP doing kind of a video conference kind of consultation, but they're missing the information, missing the data, health data, and this is opening up opportunities for people doing research in this area, because this kind of telemedicine, telehealth, or with the sensors, even if we also have the actuator, even better, we can introduce interventions. So be able to treat at home, and also minimizing the traffic, minimizing the social interactions, help containing the virus spreading. And in fact, we believe, or I believe that like even after COVID is gone, we will never going to go back to what we used to be. Our lifestyle will probably already change. Our society has already changed. In terms of delivering healthcare, it needs to be changed. And it's forcing all the governments, all the healthcare services to make this big step of changing their infrastructure, changing the way they provide their services. Because what happens if there's another COVID coming, right? That's what I was thinking. That's why it is kind of opening up opportunities that can really accelerate of what we have in terms of technologies and putting to the next level, going to the patients, helping all these people to treat at home.
Thank you. Very nice discussions. I'm wondering if there are other leaders that would like to comment on this. Please don't hesitate. Please, Professor.
Okay, so with respect to COVID and the consequences for our healthcare system, I agree it is not a very deadly pandemia. It's still, but we will see what the end really tells us, because the Spanish flu was also 3% of casualties, which was then going up to 6 when we had bacterial superinfections, right? But in the normal case, 6% is not that far from what we see so far. Maybe we are ending at 2% or something like this. So it is a big one. And I completely agree. It will be, or it would be wise and quite strategic if we think of rapid pandemic response as a research question for the future. Because we have no structures. We are operating our industry in a slowly adapting fashion. We have steady state with slowly adaptations, and we have never been challenged to respond so quickly. And this is completely instationary. And that, I think, all the regulatory things, but also the question of how do you have flexible production issues when you have scarcity of parts that you could not buy, because everybody is buying parts of components like hell. How do you do that? So there is a lot of research, I think, and the next pandemia will be similar to this one. SARS-1 was in 2003, remember, only 17 years. MERS was in 2009, and so was the H1N1 flu, which is not that far from what we are seeing now. All these diseases come more and more regularly as we penetrate the animal kingdom so severely, and they will come again, and we better prepare.
Thank you very much. If there are not other comments on this specific topic by other leaders, we could go to another question, which is connected to the previous discussions we were having with the Professor Pecchia. And essentially, they are asking if the artificial intelligence will be useful for Africa and for other countries that are in the same situation with low supply capacity. Basically, they are asking how we can address the bias and, I guess, the gap in medical knowledge. Many medical studies are carried out on white population, they say.
This is really true. This is so very much true. This is so unbelievably true. And it's not only true for Africans, that's true for gender, sex, as we say in biology. So there are not enough balanced study. And I don't think about human being. This starts much earlier. When you are doing a phase 0 study for a drug in a cell culture, are those cells 50% female and male or not? Are those coming from the same group population or not? So there are big issues in research, and it starts much earlier than a phase 4, much before you start targeting human beings. It's not only for Black people. Also, there are literature supporting the fact that there is an underrepresentation of Asian samples in many studies coming from the States and from Europe, which is true. Which is reasonably true. I've never seen the numbers, but I would expect so. So this is a big issue. Science is not yet balanced in many ways. Gender is an exemplar. Paolo started saying how important it is that we still support, and we still support female because there are not enough. I mean, this panel, unfortunately, we are all male and many of us white, and many of us in the same range of age, 40, 50, and that's a shame. We should have had here a Black woman scientist, 20 years old, not because she's Black or woman, but because of her merits, and there are plenty of people like that. So there are still a lot of biases in science. As mentioned before, IEEE is doing a lot. The women in engineering and biomedical engineering, the task group are very active. The same in Europe, YAMBES, and in the world, IFMB, IUPES, and WHO also is very proactive in balancing those issues. And as I said, not just at very high level, human being, but even when it starts earlier with the cells and biochemical kind of things, because there you start balancing things which may be relevant in future. So yes, this is a big problem, and but it's on the radar. So I want to be positive. So science is now targeting this much better. As a General Secretary of IUPES, the World Society of Biomedical Engineering and Medical Physics, we are part of the ISC, the International Science Council, which is the United Nations UNESCO body for science and knowledge. And the work they are doing for balancing those differences in science is amazing. So my suggestion is to keep an eye on what the ISC is doing in this area, and many other scientific societies are doing very well. Some countries still lag behind. We can discuss if Italy is doing well or not in comparison to the UK or Finland, but still there are gaps that we need to face and solve. Some problems are there, I mean, have been already anticipated, but I'm positive. I mean, there is a lot that we are doing and we have to do. I don't know if I answered this question.
I think so. Thank you. There is another question for a very general one, actually, for Dr. Bruna. They are asking, how is SAT microelectronics approaching to the GaN technology? I mean, which is the impact of this technology on the market? So it's a very general question, which I believe could be very interesting.
Yes, I have to say that I'm not fully involved in this technology. It's a brand new one. We in ST are focusing on it from years. And there were a lot of problems in terms of technology and stability and so on, other problems. But about the impact on the market, we hope it will have a deep impact because advantages of this technology is very very fine in terms of power consumption, for sure. We want to, and as far as I know, but again, I'm not an expert on it in particular, we want to start using it in automotive products. And for sure, it will, when this technology will be very satisfactory in terms of how to say, reliability of the products. Probably it will exploit or will be exploited also in other markets. But again, I'm not an expert on it, so I just say what I heard. I don't know if Danilo.
Yeah, I think it's enough, at least in this context. Probably we can move. So if there are no comments on this from other leaders, we can move to the next question. They are asking about Professor Wei Gao that yesterday presented the lab on skin. How this technology can impact the market in the next 5-10 years, and how they can be suitable for mass commerce as medical devices. So this is very much connected to our main topics here. Anyone has some good thoughts on this?
Yeah, I can probably put some comments because of course I was not in. I have not attended the talk, but in terms of this kind of skin type sensor, it's a very exciting area of research, looking into making it more in terms of user compliance. It could be better because you simply stick on stick on the skin, and it is moving towards that direction in terms of the sensor design, making it more slimmer and also easier to attach to the body. As when we first started our research, our sensor is quite massive. When I gave a talk to a group of students some years ago, I showed them, yeah, this is the very smallest computer or sensors in the world, and they, oh, it's still quite big. The comment is still quite big, but nowadays we can make potentially very thin, very easy to attach sensors, and this type of devices could potentially change the way medical devices, rather than big machines, rather than a wristband or so on, is attached, just stick onto your skin and providing those measurements. And yeah, there could be a massive commercial potential, but probably I'll leave this to the experts in those areas.
Okay, thank you. I go ahead if there are not other comments by leaders, since we have another interesting question, and it's about non-government organizations and supranational organizations such as NATO, ONU, can help the research in wearable technology and artificial intelligence. Nowadays, are there some research grant and money aid for young researchers in this area that you suggest to apply on or to consider it in general? This is a very...
I'm happy to take this one if...
Please.
Yes, there are. If you read their websites, you find plenty of opportunities. I'm now the innovation manager for the WHO initiative on research and development of PPE for COVID. which was launched December last year, financed, I guess, from the Bill Gates and Melinda Foundation plus the German government. And that's just an example. So they announced this call for up to 20, more or less 15 projects of research in order to enhance PPE in response to COVID. We know that personal protective equipment is key. There are many other opportunities, not only WHO, many NGO, they have calls for specific requests. And normally they're very interesting because they come from the real world, the real need. And so they ask for pragmatic solution. So it's technology oriented eventually, or transfer oriented. But yes, there are plenty of opportunities. IEEE is a member in Europe of the AMBES, which is a member of the IFMB, and IEEE is also a member of the IFMB. If you keep an open eye on the IFMB website, in particular the Clinical Engineering Division and the Health Technology Assessment Division, they often announce those calls, and they're very timely. Yes, and the early career are very welcome, and normally they have specific calls for facilitating just travels and meetings and stuff like that, which you can find very, very useful and interesting. I would suggest to attend the forthcoming WHO Global Forum of Medical Device. This will be the 5th edition, I guess. I don't know now with this pandemic situation where it will be endowed, probably will be virtual. But that's another good place. If you are in the space of biomedical engineering, what we do are medical devices. So if you want to know what NGOs in this field are doing, then keep an eye on the Global Forum of Medical Device of WHO. I've been chairing sessions there since 3 years, or 3 editions. And I must say there is huge attention to early career folks as far as they are keen to work for real problems and not just theoretical issues.
Perfect.
Happy to share the links if I can in any way.
Thank you. Thank you. Probably you may share the link within the chat, because so that they can give a look almost in real time. So there are other points, other comments on this by the leaders. If not, I'm giving a look to your picture. Okay, your microphone are muted, so I guess there are no other points. For Dr. Guger, how your adventure in the industry started and why you got in this research field? This is a very interesting question.
It's also very usual. So I studied in Graz at the University of Technology, which is a big university with 40,000 students. And then I didn't know what's good. So I went to the US and studied at Johns Hopkins University with Nitish Dekar and so on in the biomedical engineering field. And in the US, they mentioned a professor from Graz, from Austria, Gerd Pfurtscheller, who is one of the leaders in the brain-computer interface field. And of course, I didn't know him because he was too close. And then I returned to Graz and started my master thesis and later on my PhD with Gerd Pfurtscheller. So it's always the same. You have to go far away to learn to know what's good at home. It changes the perspective, and then I did my PhD. And doing my PhD, people were already asking me if I sell the brain-computer interface technology. And so I just started GTEC already doing my PhD. And when I got my PhD a few weeks later on, I sold the first system to Oxford University in Great Britain. And the second system went to South Korea. And this is how GTEC more or less started more than 20 years ago. And at the moment, we're doing a lot of research. So we have many publications every year. The whole team, we have a lot of PhD students and PhDs running these research projects. So basically, my work is not much different from being at the university of doing research, but we are much more independent. So I'm not so much dependent on research grants, because we are selling a lot of hardware and software components, and that's of course paying also for research. And a big advantage is also that my team is very stable, so the team members stay for a very long time, and they don't quit when the PhD is finished or when the master project is finished. And this builds up a lot of knowledge, and that's also the reason why we are pretty quick. At universities, sometimes it's a problem that PhD students, as soon as they are finished, they move to another institute, and then all the knowledge goes with the student. So that this is much easier to handle in companies.
Okay, thank you for this detailed answer, and I believe it's very inspiring for young people to know about the career path of researcher, and of leaders in general. I'm wondering if there are other questions. Yes, there is another one. How much do you think it is right to devote your master thesis work? Clearly in terms of time span, I mean, they are asking how long should be a master thesis work, which is the effort, which is the time they should dedicate to this activity.
So I would say not too long.
Yes.
So I ask everybody to be finished at least after 6 months, because then you should go for a PhD or work. It doesn't make sense to make yourself busy for a longer time. So some master students, you know, they write books to summarize the thesis. That's not necessary. Be brief and quick and good. And then do something else. There's no need for endless education.
Yeah, especially this is my opinion and my experience, especially if you would like to start a PhD, it's not a good idea to spend too much time on a master thesis, because I mean, you can go on working during your PhD on the same project, on new projects, but anyway, a few months, I think 3, 4, 5 could be a good amount of time.
But isn't that normally regulated by the university regulations? I mean, there is not so much negotiations or space for negotiation here. I mean, this is in Germany, this is 6 months project and that's it.
Okay. I wanted to add something in this direction. Europe is split into the Northern European Europe as a system which is normally not legally recognized, but based on accreditation. And those systems then often they have the limited time for the project, which, as Stefan was saying, it's 6 months or so, depending from the number of credits. In the UK, it can be 1 year. Many master, they have 60 credits for a master project. And this is now very much research oriented. So it's a 1 year experience. You can do that. If you like research, then eventually you move to a PhD. If not, you go back whatever you were doing before. Southern Europeans, Spain, Italy, Greece, France, they have legally recognized degrees. They don't need accreditation. They don't need a third body saying they can be accredited, because they follow the ministry of the appropriate ministry when they dictate, sorry, it's a strong word, when they prescribe which credits to do in order to be called a biomedical engineer or not, or any other branch. In this case, no, there is not a formal limited time, but it's really between the student and the supervisor. So if the question was coming from Italy, then that's probably justifying why time is a variable and not a fixed
I think
parameter.
So. I agree.
But I agree with the answer. So how long? As much you really need, and then move forward, because the degree is great and will never come back. So you end up enjoying it too much. But what's coming next can be even more fun. So
yeah, I mean, if you feel that you are learning something, it's a good idea. I mean, you should feel that you are learning something. You should feel that are inside the difficult part, because if you are doing something that you feel that is stressing you a little bit, it means that you are learning and that you can improve yourself. If you are if it's too slow, and if you are not learning a lot, probably you are wasting time. So please don't. I mean, you should feel yourself. It's you should consider your path, your singular path. We have another interesting question and very, very specific. Are GTEC open to master thesis work from Italy?
Sure. It's always a pleasure to work with Italians. At the moment, we have actually one neurologist working for us in Palermo, Rosella Spataro. She's working on the Marie Curie Individual Fellowship. This goes very nice. because she's using our PCI systems in Palermo in the hospital to do measurements. And another student works with the University of Trento on music, emotions, and brain-computer interfacing. That's an EIT project from the European Union. And of course, we have all the time master students working with us. And you can also do it from Italy, so then the location doesn't really matter for us.
And I would add that research has no borders, but for sure. So I think that as a researcher or as a student, you should push yourself to go around, especially in Europe, because we are Euro-European and we need more Europe than ever in these difficult times, in my opinion. We have a question for Dr. Massaroni. How do you think a young student should approach the world of research?
Thanks for the question. I would like to move this question to our leaders, and I think that Giancarlo Fortino could help us in this question. So how do you think about a young students should approach world of research? Your experience, you're much more experienced than me.
Thanks a lot for, passing me the floor. This is a very nice question indeed. When I was young, many years ago, now I got the white beard. So I'm also sage, not so young anymore. I don't want to say old because I'm not old, but anyway, kidding aside, this is an interesting question in the sense that, in my opinion, first of all, a young student need to have, the interest to do research. It's a kind of sometimes brighting star in your head, and for sure, if you got this, in my opinion, the very first experience should be a very interesting thesis at the Master of Science level. This experience is, in my opinion, fundamental. It's fundamental, and you need to carefully choose, the subject, because as we said, previously, one of my colleagues said previously, you need to like your work. You need to like your work. First of all, the topic. Second, the environment. And of course, the environment involves your professor, the lab, even, whether or not you are in your local environment or you are abroad, okay? And I also think that a Master of Science thesis developed abroad could be an opportunity, okay? Majority of my students at Master of Science level did their thesis abroad, included, my, let's say, strict collaborator who is Professor Gravina, Dr. Gravina, who is one of the chair, of the workshop. His very first experience was just at the University of Berkeley in California. Okay, he spent almost 7-8 months at this research institute. So, first of all, the Master of Science thesis in research. This is fundamental, and also then the PhD. If you don't get in some PhD, of course, you cannot start doing seriously research, okay? So these two, let's say, two pair of experience are, this pair of experience is fundamental, in my opinion, because during the PhD, then you will, approach research in a more systematic way. And then, definitely PhD, again, in some interesting context that could be, local at your local environment, in Italy, in Spain, US, if you are from Italy, Spain, US, or abroad. But it should be, you have to think about it carefully, and then you have to follow what you'd like to do. this is maybe the most important aspect. Okay, but definitely Master of Science, research Master of Science thesis, and then PhD, definitely.
Thank you. Thank you again. Long life to the PhD. We have already discussed this at the beginning. So this is a new viewpoint and a very important addition to this topic. They have another question. It's a bit complicated maybe, but it deserves for sure an answer. They are asking about the research environment. They feel that in different regions of the world, the research environment is organized in a different way, and they ask if it's difficult to interface two different regions for a common goal. In other words, how much can the difference in organization be an obstacle, and how do you overcome this limitation in your work?
I can say something if you want.
Please.
So we're having a lot of cooperations with international partners. And I think, yes, sometimes structures are different and hierarchies are maybe a little different. And to overcome this, the best thing is that you have a point-to-point connection on the senior and on the PhD student level. So everyone should always have a partner. We also do this when we do cooperation projects with our clinical partners. It has to be me interfacing with the chief physicians, and it has to be our PhD students interfacing with the clinicians in charge of the specific problem on the project. I think that is very important, and people have to like each other, or at least be flexible on both levels. Otherwise, it will not work. Bureaucratic obstacles can always be solved if people have a good connection to each other, but it has to be on both levels.
Thank you. So I think this is addressing the point for sure. And I don't know if there are other comments.
Yeah, maybe I can add something.
Please.
Of course, different organizations, different institutions have their own limitations and also obstacles. But if we turn it around, think of in a different way. Different organizations collaborate together, actually create opportunities. Because sometimes, although there may be overlap of skill set, overlap of things, and each organization, international organization, in different country, yeah, maybe in some countries that they have not that much resources, but they may have other opportunities, which is other potential things which you don't have. Give you an example, we have a collaboration with some African countries. Of course, their research resources are very limited, but they have quite unique environments, which we don't have. And to develop technology for such a population of people, you need to be tested in those environments. It's not possible for us to do those research in our organization. So this is looking at a different way rather than as an obstacle. It could be an opportunity.
I agree. Every obstacle can be an opportunity for sure. So it's just the way you approach it. I don't know if there are other comments, and we are almost done. We have 10 minutes, so please don't hesitate to go ahead with your questions and curiosity. I think we believe this is a unique opportunity for you to understand, to figure out how to approach to these research areas. I have a question by myself, actually, and to all leaders. I think this point was partially addressed previously during our discussions, and I was wondering how important is the role of public funding for these research areas. So this is very important, even for industry, because very often industry also collaborate with the public funding, and there are some challenges that are so big, maybe, that cannot be addressed just by private funding. What do you think about this?
I think it depends on the country, because there are some countries that it's not easy to find private funding.
Yeah.
So in these countries, Italy is one of these countries. In these countries, is fundamental to find public funding to go on and to do research. So I think it strongly depends on the country. When I spent my period in the United States, it was a little bit different. So it's important the public funding, but you have much more opportunities to find a private funding. So you have different opportunities in different countries. I don't know what is the feeling of our leaders, but I think it strongly depends on the country.
Yes, please, leaders, some opinions on that.
I agree with Emiliano. It's strongly country and region dependent, because within the country also regions plays a huge difference. We are lagging Europe because Europe is providing a lot of support, but we also need to know very well those systems. It's different. Normally, lower tier well is supposed to be supported by national funds, and then this can become a problem in some country, while higher tier well finds better fitting at international level, Europe. So all the Horizon 2020 collaborative grants, normally they are much higher TRL apart ERC and Marie Curie.
Sorry if I interrupt you. Do you mean technology readiness level, right?
Sorry about that, yes.
Yeah,
technology readiness level. So whatever it's more closer to the market to become an innovation and something which can be used by people in little time, then the higher is the TRL. And now for these kind of things, Europe is probably the best place to look. While for lower level, normally it is expected that national public funds support this kind of research. Apart few grants, ERC, Marie Curie, which obviously they invest on the person rather than the object or the idea. And the same applies to public or private. So we use both, but obviously private is more targeted. If I'm a company and I'm supporting research, I want to get these results in this time. So it depends what you're looking for as funds. Public support comes with different pro and contra, and it depends really from what you do as a research, I guess.
Thank you for this nice perspective. And if there are no other points on the other comments, I will leave the floor to Ferdinando, that probably would like to make some final remarks, because we are.
I think there's another question for Dr. Kruger. It's about the unicorn kit.
Okay.
Okay, so we have a unicorn education kit that's a very easy to use but high quality brain-computer interface. And we developed one kit for education where a professor at university gets 8 of these devices. And then you can teach a whole semester or a 1-year course. It's similar to the hackathon. So normally universities are forming teams of 5 students, and each team is using one of the unicorn brain-computer interfaces. And when you get 8, you can actually educate 40 students at the same time. And we have a lot of tutorials available on YouTube and on GitHub. So students can easily learn how to do brain-computer interface research and how to program the devices. And then they can also work on their own applications and ideas. So they can do signal processing, they can hook it up to Arduino boards or Raspberry Pis. They can send the commands from the brain-computer interface to Unity and develop computer games. There are just many opportunities what you can do. And the education kit is also nice because it's relatively cheap, and this means you can also give the kit or one unicorn to students and they can work at home, which is also now interesting if they're not allowed to come to the university. They can at least meet at home or exchange the hardware. And then you can do very easily remote education.
Okay, thank you very much for your.
Thank you.
Yeah, thank you very much. So I think that, yeah, we are almost on time with the time schedule. So yeah, it was very nice discussion, very fruitful. And I think I will give the word to, I will thank you to the very important expert we had, and I'm very happy about the discussion. I think that all the attendees learned a lot of stuff about this kind of opportunities, challenges, pitfalls, and so on. So I thank you all for this very nice event, and I will give the word, to Carlo for the announcing the other steps of this workshop. Thank you very much.
Thank you very much to all.
Thank you very much to all the leaders. It was really an impressive morning. I just want to remember you the events of this today afternoon. We have the second day of the WSAIM 2020 workshop. We will start in half an hour, 1 p.m. up to 7 o'clock. And we will talk about artificial intelligence in wearable devices with Professor Lovell, Professor Tavares, and Ali Ramazzani from MIT. And then after a short break, we will have an overview of actual and future perspective from companies. We have speakers from Shimmer Sensing, 3M, and other companies in USA and India. So I want really to thank you again, and don't lose the opportunity to join the second session in the afternoon. Thank you, everybody.
Thank you.
Thank you. Bye-bye.
Bye.
Bye-bye.
Thank you.
I hope to see you
Bye, everyone.
this afternoon.
Yeah.